Hey, this is Tommy, and this is my analysis of the game Angry Birds. And the whole point of this analysis is to find the height of the Angry Bird. So we're going to go ahead and get started. So the first thing you want to do is you want to insert a movie. And I already pre-recorded mine earlier, so we're just going to use it. But you'd have to find your own computer, find your own video and use it. So let me get that. Okay. And mine started about right in there. So there. So the first thing you want to do is you want to click there because that lets you open up all the tools, and you're going to use the set origin, and we're going to click on the top of the bird. So for each point that we add, we're going to click on the top of the bird as well. Oh, as the graph's going to get messed up. But before you do that, you want to go to options, movie options, and you want to increase it to 3 or something like that. You can go 5, but I like putting in 3. And you have to make sure that this box is checked, otherwise the whole thing's going to be messed up. So okay, and you're going to click on the top again and keep going. Okay, and don't click it after it hits the ground because after that it's no longer parabola. So after that, what we have to do is we have to set the scale, and this is the whole part of the whole point of doing this experiment. You're trying to find the height of the bird, and we're assuming that gravity is equal to 9.8 or negative 9.8, but we're not 100% certain. But we're assuming that based on this experiment. So right now we're going to say that it's equal to 1 because we're not sure. So what you want to do is you got to change this graph to y velocity, and I'm going to make that a little smaller. Sorry, you want to make it y, not y velocity. You're going to highlight it, and you're going to click on this button up here, f of x, or the curve fit. And because this is a parabola, we're going to use the quadratic equation. We're going to try fit, and with 1 we get negative 6. But we're trying to get negative 4.9 because that's half of gravity. So we're going to set the scale again. And this time we're going to go to 0.8 meters. And we're going to do the exact same thing again. Try fit. Now I got negative 4, but we want to get closer than that. So we're going to set the scale again. Oh, cancel. This one. Okay. 0.9. And then you're going to click on that button again. Try fit. And I got negative 5.4. So we got to make it a little smaller. Cancel this one over here. It doesn't really matter that much if you use a different bird because they're all the same size, but I like using the same bird. 0.85, okay. F of x, try it again. And we got negative 4.9, which is very close actually. So we're going to click OK. And you put that on there. Now what we want to do is we want to insert more graphs. Sorry. You want to insert some more graphs. So we're going to click insert graph. And we want the y velocity because we have y. We want the x graph. So just click on it and select x. And then you're going to insert the graph again. And this time we're going to do x velocity. Now you're going to do the same thing you did for those other ones. And you're going to do curve fit. This time we do linear because these are all linear graphs. Try fit. That looks about right. This one, linear as well. Insert. Oh, sorry. Get that off. Anyways, linear. F of x. Try fit. Negative 1. That's good. And this one, try fit. Okay. So also another thing you can do, what you want to do is you want to get these out of the way. But another thing you can do is the m equals, because that gives you the slope at each point in the graph. So you can like you can move your mouse over a certain part of the graph, and it'll tell you right here where what the slope is at that time. So that's it for my analysis. Hope you enjoyed the video.